So for today's lesson, we're going to talk about radicals. But first off, what are radicals? Radicals is when n is called the index, a is called the radicand, the squared sign is called the radical. The right side of the equation is often called as the radical form, while the left side is often called as the exponent form. There are different operations on radicals. First off, addition of similar radicands. When adding radicands, there are two things to remember. First, if the radicands are similar, simply put, n equals the number of times the similar radicands are added to each other and multiplied to the radicand. The equation goes like this. A concrete example is I'm going to give an example of subtracting with different radicands. As you can see, 3 square root of 2 doesn't have a partner, so we'll leave it as it is. Then we're going to subtract 4 square root of 7 by 2 square root of 7, which leaves us with 2 square root of 7. So this becomes the whole answer. 3 square root of 2 minus 2 square root of 7. When multiplying, simply multiply the radicands, but if they are similar, remove the radical sign after multiplying. The equation for multiplying goes like this. This is for similar. While if the radicands aren't similar, it goes like this. An example of which is since the square root of 64 is 8, we'll leave it like this. And since there's no square root of 3, so we'll also just write down square root of 3. Then this becomes the answer. When dividing, one of the rules in radicals is we shouldn't have any radicals in the denominator. When you rationalize, we'll multiply the root to itself to remove the radical sign. So the equation goes like this. An example of which is then you multiply it like this. So there will be no radicals in the denominator. So to get this, you just simply multiply 5 divided by 5 times square root of 9, then 5 multiplied by square root of 7. Then this happens. 5 square root of 9 plus 5 square root of 7. Which leaves us with So this is a final example of a radical video.